Hi students, all of you welcome. Welcome to Sunil Engineering Academy. I am Sunil Kumar Bandaru. Students, in this general science, physics, we have completed two sessions, electricity and magnets and magnetism. If you want previous, you can watch in this YouTube channel. And these sessions are useful for all your competitive examination, wherever there is a general science is a topic. Okay. And after this electricity, magnets and magnetism, we are going to start with the next topic, that is work, power, energy. Okay, after that force and motion will be started. So now we are going to discuss very important topic, work, power, energy. Okay, so first of all we are going to discuss the work. Okay, I think all of you know very well about the work. Work is nothing but force into displacement. F is the force in newtons. Okay, S is the displacement. Displacement in meters. Okay, in meters. So here force newton, displacement meter means, so work unit may be newton meter, and 1 newton meter is equal to joule. Very important, work units are newton meter and newton meter is equal to joule. So generally we can say in SI units are joule. Units are joules. Okay. For example, if we have the angle between the force and displacement, if we have angle between force and displacement, then what is the formula? W is equal to Fs cos theta. Fs cos theta. Okay. So we can define the work. This is nothing but work is said to be done whenever we apply some force, that body having the displacement in that same direction, then you can say work is to be done. Okay, so note down, work is said to be done by a force F force when it has the motion, or when it produces motion in the direction of force, in the direction of force. Okay, if it has one body, if you apply the force in the same direction of the force, if it is having the displacement, then work done is equal to Fs. Okay, so here the angle between the force and displacement, here theta is equal to, both are parallel 0 degrees, so cos 0 is equal to 1, so you will get W is equal to Fs. Okay, so according to the physics, whenever there is a force and displacement, then only work is said to be done. If displacement is equal to 0, work done is nothing but 0. If the force is 0, work done is 0. If the cos theta is 0, then also work done is 0. Okay, so if S is equal to 0 or cos theta is equal to 0 or force is equal to 0, in any of the cases, that is in any of the case, work is said to be 0. Okay, cos theta is equal to 0 means theta is equal to 90 degrees, correct? So that means if force and displacement having 90 degrees angle, then work done is equal to 0. All of you clear? If there is angle between the force and displacement is 90 degrees, then also work done is equal to 0. For example, if a person standing on a platform, any platform weighing 10 kg suitcase, then what is the work done? Here he is just standing, means what is the displacement? Standing means displacement is equal to 0, so then work done also 0. For example, if you apply the force in this direction, if your displacement is in this direction, then what is the angle? 90 degrees. So in this case also the cos theta is equal to 0 because of theta is equal to 90 degrees. So in this case also work done is said to be 0 according to physics. Okay, according to physics. If there is a negative work, that means whenever there is a angle is 180 degrees, that means if you apply the force is in this direction but your displacement is opposite direction, then theta is equal to 180 degrees. In this case cos 180 degrees is equal to -1, so then work done will be minus Fs, that is negative work. Okay, so here we can say work may be positive, 0 or negative also, but if it has negative, positive, 0, but it is a scalar quantity only, is the scalar quantity only. Why? Because work is equal to F into S now. F into S, both are vector quantities. So vector into vector is the scalar. So work is the scalar quantity and units are joules. Very important. Okay. All of you clear? So work done is nothing but whenever work is said to be done by a force when it produces the motion in the same direction. In the opposite direction you can say negative work. Okay, in perpendicular you can say 0 work. Whenever there is a perpendicular angle that is 90 degrees between the force and displacement, then 0. If any person is standing, displacement is 0 now. He is not at all moving, means displacement is 0. Then also work done is 0. All these are very, very important. Okay, don't worry, we will discuss in detail in the MCQs also. Okay. Now coming to the second one, power, mechanical power. Power is denoted with the letter P. Okay, power is nothing but with how much rate we are doing the work. It means we are doing the work is fastly or we are doing the work is slowly, that is given by power. Okay, if you have the more power, we can complete the work within less time. If you have the less power, we can complete the work in so many time. That is only. Okay, so we can say that power is equal to work by time. Okay, so that means you can define this one as power is rate of doing work. Power is rate of doing work. Okay, if work is same, then if the power is high, inversely proportional with respect to time. So that means inversely proportional with respect to time means power is high, you can complete the work in less time. Okay, if the power is low, we can complete the work in with very high time. Okay, for example, the work is we have to fill 1000-liter water tank. Have to fill 1000-liter water tank. If we go with 2 horsepower motor or 1 horsepower motor, if you go with 1 horsepower motor, it takes 30 minutes. Then if you go with 2 horsepower motor, high power means it takes less time, so it completes within 15 minutes only. Within 15 minutes only. So can say high power means takes less time. Takes less time to complete work. To complete the work. Okay. Then what will be the units? Units of the power, work joule time second, joule per second. Joule per second. 1 joule per second is said to be a watt. Is said to be a watt. Okay. Here we can also define this power. We can also give the units of the power in horsepower. 1 horsepower is equal to 746 watts of electrical watts of electric power. Okay, this is also very repeated and very important. So mechanical power units may be horsepower, watt, or joule per second. Okay, so power is nothing but rate of doing work. So higher the power, lesser the time to complete. Okay, lesser the time to complete. Okay, completed. And this power also scalar quantity, not depends upon direction. Scalar quantity. Okay. And we can also go with another formula. Power is equal to work by time. Work is equal to force into displacement by time. Force into displacement by time means velocity. Force into velocity. Okay. Force into velocity. This is the another formula of the power. Completed. Now coming to the next one. Next one is the energy. Very important thing. Energy. Okay. So what is this energy? If we have more energy, we can do more work. Correct? If we have less energy, we can do less work. That means energy is nothing but how much capacity we have to do the work. Correct? How much capacity we have to do the work. If you have more energy, I can do the more work. Correct? So we can define the energy, the capacity to doing work. Capacity to do work. Okay, capacity to do work. And the units are energy is denoted with letter E. SI units, same like work, joule only. Okay, so here very important, work, energy, same units. Those are joules. Okay, and this energy also same like work power, scalar quantity only. Is also scalar quantity. Okay, we have so many units for energy. the energy units may be electron volt. 1 electron volt is equal to 1.602 into 10 power minus 19 joules. Okay, and 1 joule is equal to 10 power 7 erg. And also 1 calorie is equal to 4.2 joules. So that means calorie is somewhat of bigger unit. Okay, note on this point. These relations also important, guys. Relations are important. Note down. Okay, so electron volt is a small unit of energy, and then erg, and then joule, and then calorie. Okay, calorie is the somewhat of bigger unit, 4.2 or 4.18 joules. Okay, so here energy with respect to power, energy is also power by time. Power by time, that is power watt per second. Watt per second. This is also another unit, or generally joules. Okay, so this energy may be potential energy or kinetic energy. So that means mechanical energy is divided into two types, potential energy and kinetic energy. Okay, so if we have whatever the energy is there, that is, it follows law of conservation of energy. What is the law of conservation of energy? Energy neither be created nor be destroyed, but can transform from one form to another form. One form to another form. Either potential to kinetic, or kinetic to potential, or kinetic to electrical, or electrical to kinetical. That means mechanical to electric, electric to mechanical, chemical to electric, okay, or solar to electric. Like that, energy may be transformed. Okay, like food in our body, whatever the taken food, that will be converted into working energy, that is either mechanical. For example, if I am moving the hand means that is a mechanical energy. Okay, so energy neither be created nor be destroyed, but transform from one form to another form. Okay, so here in the mechanical terms, we have to discuss the mechanical energy. Mechanical energy is two types. One is potential energy, potential energy denoted with PE. Here kinetic energy, kinetic energy denoted with Ke. So potential energy is equal to mass into acceleration due to gravity into h. Kinetic energy is equal to half mv square. From the formula, we can get the definition. So potential energy, we are getting the energy by virtue of its height. Height means position. So if we are getting the energy by virtue of its height, if you are getting the energy by virtue of its velocity, then you can say that is the kinetic energy. Okay, so all of you try to listen. Potential energy is nothing but the energy due to its position, it means height, due to position or configuration or elasticity. Due to elasticity, then we can say that is the potential energy. If you are getting the energy due to its velocity or speed, that is the kinetic energy. Okay. Okay. So note down here, what is the potential energy? It is the energy possessed by body. Energy possessed by body by virtue of its position, that is nothing but due to height, position, position configuration, position configuration or elasticity, that is you can say strain. Okay, so energy possessed by body by virtue of its position or configuration or elasticity, that is nothing but you can say potential energy. Here, energy possessed by body by virtue of its motion, by virtue of its motion. Its motion, that is due to velocity or speed. Okay, there is no difference between velocity and speed, just direction. Velocity depends upon direction, speed not depends upon the direction. So velocity is a vector quantity, speed is a scalar quantity. Okay, by virtue of its motion, we are getting the energy, that is nothing but kinetic energy. Okay, that means anything is moving, that is a kinetic energy. Okay, so here example, energy possessed by body. For example, if the hammer is on the at the surface, it don't have energy. If you rise, it has the energy now. So raised hammer, raised hammer. Okay, water stored in reservoir. If you store the water, then water level may be somewhat of height. Due to that water level, it has the energy. Water stored in reservoir. Okay, and also stretched rubber. Stretched rubber having velocity. Sorry, stretched rubber having elasticity. Stretched rubber. And here examples: running water in river, running water in a river. Okay, and can say moving car. Any car is moving certain speed, then we can say that is the due to kinetic energy. So we have already discussed law of conservation of energy. Now that is also applicable here. So if the water is stored in reservoir having potential energy, whenever you release the water, then what will happen? Water is moving. Whenever the water is moving, that is nothing but you can say kinetic energy. So that means whatever the potential energy is there, that will be converted into kinetic energy. That will be converted into kinetic energy. Okay, so whatever the potential energy loss, that is the gain of kinetic. Okay, so according to law of conservation of energy, law of conservation of energy, whatever the potential energy loss is equal to kinetic energy gain, or whatever the loss of kinetic energy, that is potential energy gain. Okay, for example, if a ball dropped from 100 meters height. Okay, for example, here we have the 100 meters. The total is the 100 meters height. So due to the height, it has the potential energy. So at here is the potential energy. Let us take let us take 1,000 joules. It is the maximum. At this maximum height, what is the kinetic energy? It don't have kinetic energy. So I am not dropping, just I am holding it. Okay, now it is not in the movement, so kinetic energy is zero. So whenever it is coming at half of the height, as the height is half, then what is the potential? Potential energy is equal to mgh. As the height is half, potential energy is half now. So that means it is going to be reduced as to potential energy is going to be reduced as 1000 to 500 joules. And whatever it is losing, now the ball is moving. Whenever the ball is moving, whenever it is a movement, then it has a velocity. Whenever there is a velocity, it has the kinetic energy. So here it has the kinetic energy. That kinetic energy is equal to kinetic energy gain is equal to potential energy loss. Na? So potential energy loss is nothing but 1000 to 500 means 500 loss. So that is 500 here. And again, just before reaching to the earth surface at height is 0, then potential energy is equal to 0 now. As the height is term 0, potential energy 0. So whenever there is a potential 0, then what is the kinetic energy is the maximum. Maximum means 1000. So that means potential energy losses 1000 joules, kinetic energy gains 1000 joules. Correct? Potential energy loss is equal to 1000 joules, that is kinetic energy gain. So that is the law of conservation of energy. Energy neither be created nor be destroyed, transform from one form to another form. So 1000 joules it is losing means K gain is also 1000 joules. In the same way, if you throw upwards also, same. Okay. So in the dropping case, what is happening? Potential energy is going to be decreasing and kinetic energy is going to be increasing in this during the fall. Okay, in the same way, if you throw a ball upwards, if we throw ball upwards, in the upward case, what is happening? The velocity, final velocity is going to be 0. So velocity is decreasing. Okay, so if you throw any body upwards, okay, so the velocity is decreasing. Velocity decreasing means kinetic energy decreasing. Kinetic energy decrease means potential energy increasing. Why? Because the height is increases. At 0 point, at 0 height, potential energy is 0. And you have applied some with velocity, with initial velocity, you have to throw upwards. So it has kinetic energy, let us take 1000 joules. And whenever it reaches to the maximum height, as the height is equal to somewhat maximum, then potential energy is maximum. And at maximum height, what is the velocity? Is 0 now. Velocity 0 means kinetic energy is 0. So 0 to maximum it is increasing and maximum to 0 it is decreasing. Okay, at half of the height, height is equal to half means potential energy is going to be half and kinetic energy also going to be half. And above this, height is more. Height is more means potential energy more, kinetic energy less. At this 3/4. At this 1/4, height is just to 1/4 of the height, potential energy is less, kinetic energy is more. Okay, so like that you can understand this. All of you clear? So PE is equal to mgh, very important formula, and Ke is equal to half mv square, that is also very important. From that one only you can understand the potential and the kinetic energy. Now coming to the next important momentum. Momentum is denoted with the letter P. P is equal to product of mass into velocity. Mass into velocity. Mass kg, velocity meter per second. Kg meter per second. Okay. Kg meter per second. Now coming to rate of change in momentum. Rate of change in momentum is equal to dash. So come on, rate of change in momentum means we have to differentiate with respect to time. Then mass is a constant, then dv by dt. dv by dt is the acceleration, that is m into a. M into a is equal to force. Okay, so rate of change in momentum is nothing but force F. Is nothing but force F. Okay, if there is just change in momentum, dp is equal to force into dt. Okay, force into dt, that is change in momentum. Dp is equal to just change in momentum, not with rate. Change in momentum is equal to F into t. F into t is nothing but impulse. So dp is equal to impulse force. Impulsive force. So change in momentum is nothing but impulse. Impulse is nothing but force in a short duration. Force into time. Force in short duration. Okay. Impulsive force, that is equal to force into time. Okay. So note down impulse force, impulse units. Force Newton into second. Newton second. Okay. Newton second. That means if you strike any ball from the bat, it will have the momentum. That momentum is generally equal to impulsive force. Or whenever there is a bullet is fired from the gun, that is also having the momentum and also impulse. That change in momentum is equal to impulsive force. Okay. Now relation between Ke and momentum. Relation between Ke and momentum. Okay, this is the last topic in this. Don't worry. And one more important thing, in the theory only, the recorded sessions. After this theory, we will practice the MCQs, that may be live sessions. Okay. So Ke formula. Ke is equal to half mv square. Momentum is equal to mass into velocity. Mass into velocity. In both formula we have mv is there, but mv square is there. To get the square, I am squaring here both sides. Then I want only mv square now, so send one m to this side, v square by m. So substitute that one here from 1 and 2. 2 substituted in 1, then K is equal to half into mv square plus we have p square by m. So this is the relation. If p is constant, then K is inversely proportional with the mass. Okay, K is inversely proportional with the mass. Ke1 is to Ke2 is equal to m2 is to m1, inversely proportional. Okay, that means higher the mass, lesser the kinetic energy, whenever there is a momentum is constant. Okay, we will discuss the problems in the MCQ session on this K and momentum. For example, if the K and momentum both are equal, then what will happen? What will be the velocity? At what velocity K and momentum are equal? At what velocity Ke and momentum equal? Come on, try. So whenever the Ke is equal to momentum means K is equal to half mv square momentum, mass into velocity, m cancel, v cancel. Then we have the v is equal to 2 meter per second. So whenever the voltage, sorry, velocity is 2 meter per second, then k and momentum are equal. In this case, ke is equal to momentum. Okay, k is equal to momentum. Okay, students, in this session we have done a lot. That is work, power, energy. In that energy, we have completed potential and kinetic and momentum and impulse relation between K and momentum. Okay. Okay, students, in the next session, we will discuss force and motion. All the important topics. Don't forget to attend. Okay. And one more request that you have to please share the sessions to all your friends. And also please click on like option. And if you have any doubts, you can also give the comment. In the previous session, one student asked in the comment, that is, sir, permeance is denoted by. Permeance is denoted by P. Okay, so it is in the magnetical terms. In case of comparing with electrical, permeance is same like conductance. Conductance, sigma. Okay, so here in the magnetic, if we have reluctance, reluctance denoted with the letter dollar or S. So in the same way here, resistance R. Okay, so like that, if you have any doubts, I will try to clear. Okay, so you have to do a small thing. You have to watch each and every session, and you have to click on like option if you like, and you have to share to all your friends. Okay, so let me see how many students will give the comment and how many students will click on like option. Okay, thank you guys, all of you, take care, bye.